For section 8.4, day 1, we yet again solve equations. This is another style of equations in a long line of equations that you guys have been learning how to solve. And if you remind yourself again of the fact that everything you learn in this course really is just a tool for something coming later on. This isn't the end product. You kind of start to understand, at a higher level of math where you're applying it to a real world situation in a real job, often you're gonna have to be able to solve equations to get a certain value for whatever you're doing. And so a log equation, again, is our next type of equation that we need to learn how to solve. Now, in your PDF notes, I'm jumping right over number 1, but I will just kind of promote it. What are some of the things you need to be able to do? You need to be able to do a rewrite where you're looping things around. You need to know the laws of logarithms very well. And then I put a star down saying that it's really important to know that no two equations follow the same process. You don't just look at one equation, memorize the steps, and then you just keep applying it to different numbers. When you're solving log equations, just like any other senior math equation, you got to be ready to adapt to new scenarios and just again settle down and use the things that you've learned. So let's jump right into number 2a. In number 2a, what we have is log 6 and then 2x minus 1 equals log 6, 11. So here we have an equal, therefore we're solving an equation. And in this guy, the process to start is an equality. We've seen this before. Here's a little do not write down zone. We've seen things like this. If you had 2x minus 1 equals 2, 3x plus 4, if the 2's are the same, you can just drop them. And in an equality, you could say the exponents are equal. We're going to do that same idea. What we are going to do is we're going to look at this and say, well, I have a log base 6, a log base 6, those are the same. And then I have the 2x minus 1 and the 11. Well, if the log 6 and log 6 are the same, the 2x minus 1 and the 11 must be the same as well. And that's true, it's an equality. And when we solve this, we slap the 1 over, we divide both sides by 2, and we've solved it. If we put a 6 here, we have solved the logarithmic equation. It means we could put 6 back in and it's the same, and that is very obvious. You put a 6 here, 2 times 6 minus 1, yep, we got an 11. We've just solved the equation. I just want to remind you guys that no two problems are the same, and it's obviously going to get a little bit dicier than that in some areas. So let's jump to letter B. In letter B, number 1, you hopefully are now aware of the equality, just like here. We have a log 3 and a log 3, but we can't quite drop the log 3 yet and just jump into it. What we need to do is just deal with the 4 first, and that's very easy to do. What we know is that a power can be brought down or back up, whatever suits your needs. Those are the laws of logarithms that you need to know. And here's where we are. Now we have just a plain log 3 with no coefficient, a log 3. We can drop the log 3's in the equality, and you would see very quickly that it's 3 to the power 4. 3 times 3 times 3 times 3 is 81, and we've just solved the equation. If I put a 3 here, that is the value that would satisfy the equation. For letter C, let's move away from the equality. That is one thing that happens. You can keep an eye out. That's like a theme, but it's not the only thing that could happen. There's many different things that could unfold. So when you take a look at the next example, you'll understand every step, but you just maybe wouldn't have seen it coming on your own. So we have a log 2 and then x plus 3 squared equals 4. We're trying to find the value that would satisfy this, that would solve it, make it true. And you can't do the equality. There's no log 2 on the other side of the equal sign. Here is how we have to start this guy. We have to do the rewrite. We have to be able to take a log and rewrite it exponentially where you do the loop around, where you start with the base 2 to the power of 4 equals x plus 3 squared. And I know that looked weird. We've done it before, but just with easier terms, we still just did the loop around. Now, at this moment, you might be like, what? Am I supposed to just look at this and say what it's equal to? No, let's do a little bit of tweaking, and then you'll be all over the idea because it's something that's been said many times to you. 2 to the power 4 is 16. If we FOIL this out, it's x squared plus 6x plus 9. And now here's where you'll be all over it. When you look at this, there's a very common theme in high-end math. Why don't we bring everything to one side, let it equal 0, and and factor it. And this guy factors quite nice. X plus 7, x minus 1, and now we have our two values. X equals negative 7, and x equals positive 1. So again, as I promised you at the start, I knew you would understand every single step, but you just wouldn't have seen it coming. That's where the experience comes in. As you gain experience doing these, you will start to have an idea, a clue of where to begin, and often you're going to be right. So let's go to letter D. In letter D, we have 15 equals a 12, and then plus just a log x. So this guy starts off where it's not an equality again. There's no log on this side. And I just want to remind you guys, if you don't see a base, it's assumed to be a 10. Now you have to do something even before you do a loop around. That 12 is in the way. What we're going to do is take the 12 over, subtract it over, and we just get a 3. And then we have equals a log. And then again, it would be assumed to be a base of 10 and then an x. Now, I'm going to do two things. I am going to bring in the base of 10 right there. And then I'm going to put the 3 on the other side. It's okay just to reverse the equality because now it'll be very easy to see. We do the loop around, we rewrite it exponentially. 10 to the power 3 is equal to x. So we have 1,000 is equal to x. We have just solved this equation. If I take 1,000, put it back in, this side will be equal to 15. So now, again, all in the name of no two equations are really exactly the same, just different numbers. For our last example, okay, it looks like quite a big one, and it's, again, a really rewarding finish. And I know you're probably glancing at the PDF notes, and you see, oh, yep, yet again, we are going to factor in how the old saying goes about factoring. If you can't factor, all right, now let's just take our time, since this is again the end of the day. You could be teased a little bit into thinking you can have an equality. You see a log 2 and a log 2, so you're like, oh, can I just write down the other things? No. The 3 is in the way. It does not have a log 2, so we have to do something different. Now, you probably wouldn't have seen this coming on your own, but just watch what we can do. I'm going to take this minus log 2x minus 4, and I'm going to add it to the other side. So it would just have the log 2 x minus 6 added to log 2 x minus 4, and then we have just the 3, just leave it alone. Now here's what we're going to do. This addition means that we can smash this guy together into a multiplication. Those again are the rules of logarithms that you have to memorize. And now we can do the rewrite. Now what we can do is take this 2 to the power of 3, let it equal the x minus 6 times x minus 4. Remember when you loop it around? And it's the exact same as example D. This is 8. Foiling this out, I know it seems counterproductive. You want to swoopy swoop right away, but that can only be done when it's equal to 0. So we have an x squared, and then we have a minus 10x, and then a plus 24. And let's bring everything to one side. Let's let this guy equal 0. Let's factor him. And now we can swoopy swoop into 2 and 8. Now, I just want to repeat it again, and I'll only do this one more time because we only have one more lesson for chapter 8. You go through solving a log equation, and you understand every step once we go through it, and then someone says, okay, well, what is a logarithm? Like, really, what is a logarithm? Right now, because you're not seeing how they apply to calculus or chemistry, some real-world scenario, don't forget. Okay, what I want you guys always to memorize is the graph. The graph of a logarithm can really calm you down. It is the inverse to an exponential graph. And I'm not saying that this is your get out of jail free card, that this solves all of your problems in life, but it's a very, very good way to calm yourself down when you're wondering what is a logarithm.